Okay, so as stated, please get started on your homework, and if for whatever reason just you can't even get past part 1 where you just download the file and then you click knit, if you can't get that part working, come to office hours and I'll help you through it. Okay, please try it out like today or tomorrow, all right, or like at least tonight, so that if you're running into that issue, you come to office hours tomorrow, so at least you have a couple more days to work on the rest of the assignment. You don't want to I mean, you can, but I would prefer, I'll say this, I would prefer if you don't show up on Thursday office hours than say I can't get this to knit at all, right? Because that would tell me like, yeah, I haven't even tried it until Thursday. But I mean, even if that's the case, even if you haven't tried anything until Thursday, like I would rather you come to office hours and just say, sorry, a bunch of other stuff was happening this week and I didn't get around to it till now, and now I need help because it's due very soon. I'll still help you out, all right? No shame, no judgment, but I would much prefer if you guys at least tried it and get started on that. Okay, and I didn't realize, you're like subscribed to a product, and so you don't realize when other people are not subscribed. And so apparently that New York Times birth control graphic is only available to subscribers. So my apologies. So I took a screenshot of it, and it's right here. Let me just show you very briefly what it was supposed to look like. Just because there is an interactive element to it. It's like the interaction, let's see. Okay, so this is what it's supposed to look like. If you've got money and you're paying for the New York Times, right? So anyway, this is the extent of the interaction. So I think I've in the thing I have it like hovering over one of these spots here. But basically, as you move your mouse, it will update this label in the corner based on where this dot appears. Okay. And so the dot right now, this top line is for typical use of the birth control method, versus the lower line is perfect use of the birth control method. Okay, so perfect use looks like this, typical use looks like this. Okay, and then so the number in the corners kind of fluctuate, okay, between typical and perfect use for across all of the images. So that's the interactive part. There's, I think I just took a screenshot of one so you can kind of see it, but as far as interactive elements, this is how it goes, which is a good way, I think, right? Because without it, you have to kind of just eyeball what the values are. But then with it, you being able to hover over the actual value, you can actually see the actual number. Okay, so that's the interactive part. Apparently, you need to be subscribed to the New York Times to figure that out. But that's what we have there. Okay, is that all right? You can just kind of see how this works. So. Anyway, that was that element there. Okay. All right. Any other comments, questions, concerns before I get started? Yes.
For part 1, one the instructions is that we have find two graphic displays and analyze it.
Yes.
And you have provided an example graphic display, but we're not supposed to.
Yeah. Don't use the example one. Okay. I want you to go like there's lots of stuff out there, right? Any news website, there's lots of things where somebody will have some kind of data graphic, and then you go to if you're into sports, certainly there will be like a thing about sports. You know, if you go to, yeah, most news websites, if you click through a few articles, you can probably come across something. There's a subreddit called Data is Beautiful, which I don't know how, you know, there's some good ones out there, all right? And then there's a bunch of junk ones too, okay? So, you know, you'll find lots of examples of good and bad, okay? So wherever, you know, I think it's reasonable to ask you guys to find two on your own.
So
Okay?
we use any graphic display we find.
Yeah, any kind of graphic display, include a link to where you found the thing, and then talk about like what makes it either good or bad in your opinion, okay? This is just to get you to start thinking about these things, right? Yes, another question.
Are we supposed to finish reading the chapters before we answer the questions?
So this is always the question of how much reading should I be doing? As much as you're able to do, okay? The reading is there. You know, if you have the time to read through the entire textbook, great, okay? And if you don't, then you'll probably also be fine, okay? I mean, you'll survive, and certainly there's a lot of good information there, but you know, you've got this class, you probably have 2 other classes, maybe 3 other classes, hopefully only just 2 other classes. You might be doing other stuff. Other classes are giving you reading, so you gotta balance things out, right? You look at your homework. If you can do the homework without doing any reading, okay, then you're in good shape. But a lot of times there's good information in there, okay? So it's different from like a literature class where there's no way you can do the homework, and I mean, you shouldn't be able to do the homework in a lit class if you didn't do any of the reading or something, or even like a history class, but sometimes you can kind of hack your way through it. But so anyway, up to you, okay? Oh, all right, reminder, daily symptom monitoring. You guys got to do that every day. If you forgot to do that, please do that. Okay. All right. Oh, another thing. So you guys finished your first thing of data camp homework. I think almost everybody did all of it. I think maybe there was a couple students who might have missed like the 3rd chapter or something. You can still do it. You'll lose points for it being late, but losing points is better than getting a 0. But anyway, I need you guys to enter your name into your account settings, okay? Because right now it just says account that belongs to this email address. Now, some of you already have your names, but I'd say only like 30% of you have your names in there, okay? So the rest of you need to go to Data Camp Profile Account Settings. Please enter your first and last name. Just because I have to manually enter your homework grades from Data Camp into the gradebook. It's a little bit annoying, but that's what we get for the free tier. If I wanted it automatic, I got to pay more. I don't want to do that, all right? So we'll take the manual labor. And actually, it's not me. It's my poor grader who has to do this. So, but at least the grader gets paid for their labor. So we thank you. Okay, today we are going to talk about data wrangling, okay? And data wrangling is kind of, it conjures up this idea of, you know, being a cowboy and you're trying to wrangle your herd or something. But it's the idea of taking the data and like trying to work with it to get the summary pieces of information that you want, right? Things like you got a column of numbers and you want to calculate the mean of that column, right? There's a lot of tools already in R that enable a lot of these things. But in particular today, we're going to look at a set of tools known within a package called dplyr. Dplyr is part of the larger set of packages called the tidyverse, of which ggplot is part of the tidyverse. dplyr is part of the tidyverse. There's a few other things in the tidyverse that we'll also cover in our course. I also have to put a disclaimer here and say you're getting this content now, and you might see the same exact content in the future as well. This being a brand new course, so in the stats and data theory majors, there's a few pathways of classes, but right now you're required to take stats 15, this class. You'll take stats 20, and then you'll also take stats 102A. Now, the thing is in stats 20, you've got a few different instructors. Some of the instructors will emphasize more programming issues, and then some of the other instructors might also cover the tidyverse. So if you take stats 20, say with Professor Tsang, you won't cover dplyr again. If you take it with Professor Liu, dplyr will be covered there. Okay. And then in stats 102A, which I sometimes teach, because for 102A, this class is not a prerequisite. Only stats 20 is a prerequisite. But then again, when people come into stats 20, I don't know if they've seen dplyr, if they haven't seen dplyr, so I end up covering dplyr again in 102A. So depending on your pathway, you might see this like 2 times or 3 times in your coursework. And all to say, it is an important thing, and I think it's okay to get exposure to it multiple times. But yeah, I also apologize for the amount of overlap that we've currently have in our different courses. And I think we're trying to figure out the exact kind of curriculum, but as a new class pops up and we have to make adjustments, it's it's not going to be always as clean as we would like. Okay. Anyway, we load that up using library dplyr. If you have, or library tidyverse, if you've already done install.packages tidyverse. So you should only have to do install.packages, the name of the package, like basically one time on your computer, and then maybe periodically you do it again every couple months because they'll release updates to these packages. But it's not something that you'll have to call every time. Whereas the library, you're going to call that like almost every time every single time you have to use it. Okay, so we're going to take a look. This is, you can read chapter 4 in your textbook, and it works through the same kind of stuff, but with a different example. And today, I'm going to be following some examples from the dplyr vignette. And let me give you, where did I put that card with the answers? Your first view quiz answer today is the letter A. A as in apple. A as in apple is your first view quiz answer. All right. A as in apple. Okay. So anyway, this just says, hey, the reason why we use dplyr as part of the tidyverse is that, we want to figure out what we want to do with the data, and then we got to write it in computer instructions, and then we do it, right? And dplyr, they say dplyr is great because there's only a few options, and if you only have a few options, you got to it's easier to kind of master the few options that you have, and you can kind of figure out how to string them together. So, part of their argument is like, it's not a bug, it's a feature in that the fact that you only have a few options for what you do, but really with these few options, you can really achieve everything, almost everything. And that's a good thing, okay? These are basically the options that we're going to be using. Select, filter, mutate, arrange, summarize. Okay? And then we also pair these up with group by. And this is how it goes, okay? Select, you pick the variables. Basically, you're selecting columns. Filter picks the rows. So you filter out which rows you want. Mutate allows you to create new variables. Maybe mutate pairs up with rename, where you can rename some of the variables. Arrange allows you to sort them. And then you have summarize, which will do things like calculate the mean or the variance, or some kind of summary value here. There's a cheat sheet, which is handy. Kind of lists off a bunch of these things, and you'll see there's actually more than just these 5 verbs. Okay, there's more, but a lot of these are like special cases of these things. Okay, well, in our later this week we'll also look at combining tables. What I want, if you have a laptop, bring it to class on Wednesday. Okay, on Wednesday we'll spend we'll work through together an example of some data analysis or something. Okay, so if you have a way to kind of do something, bring it to class on Wednesday. If you don't have one, that's okay. Maybe you can sit next to somebody who does. All right, and you can kind of watch and follow along. But if you've got one, bring it, and but unless your like laptop's like super old or something, and it's like 20 pounds, or I don't know, you got like one of those super gaming laptops, which is not really meant for portability, whatever, I leave it up to you whether you want to bring it to class or not. Okay, but we'll work through an example on Wednesday. Okay, so the first verbs that we'll take a look at will be select and filter. All right, and the example that we're going to look through is this data set. It's the Star Wars data set. It's part of dplyr, and it includes information about various Star Wars characters from the first 7 Star Wars movies. Okay, and I don't know if you are fans of Star Wars or not, but they were released in this kind of funny order. First was Star Wars, and then they decided to name it Star Wars A New Hope, and that was episode 4, and it went out 4, 5, 6, A New Hope, Empire Strikes Back, Return of the Jedi. And then they released the prequel trilogy, episodes 1, 2, 3, and then now we have the sequel trilogy, episodes 7, 8, and 9, and I guess that defines the Skywalker saga. This data set was created after episode 7, before whatever. Okay, there's a lot of characters in these things. Most of them are human, because guess what? That's the kind of actors we have, and so that's what our movie set is. And so apparently there are, in this data set, we have 87 named characters. Okay, so these are characters that have names. I mean, obviously there were lots of people, but not all of them have names. And somebody went out on, I don't know where they got this information, because it's not like they said ever in the movie, hi, I'm Luke Skywalker and my height is 172 centimeters. But they obtained this probably from either the actor information or some Star Wars Wikipedia thing, Star Wars Wiki. Okay, but anyway, we've got the information on their height, their mass, their hair color, their skin color, their eye color, the birth year, which is, we're getting too much into the Star Wars universe here, but it's measured in from, there's a 0 point as far as time goes, and apparently the time is like human years. So this is before the Battle of Yavin, if I have this correct. So this is where the Death Star blew up. Oh, spoiler alert. And that's considered the year 0, or the year 1. You have time measured from before, and so Luke Skywalker is 19 at the time of the Death Star explosion, and that's where that happens. Whereas C-3PO is 112 years, because Anakin had fixed him up from whatever. Okay, and anyway, we have sex and gender and their home world and their species and things like that. Okay, there's even more variables. Which films did these characters appear in? What vehicles did they ever command or operate? What about starships? Okay, vehicles being things like cars and speeders, starships being their spacecraft. Okay, so anyway, select just works by saying, hey, you got a bunch of these, you got 14 variables. This is too much stuff. In fact, I can't even fit all 14 variables in the display here. I only really want to look at these 4 variables, okay? And so we have select from dataset Star Wars. These are the 4 variables I want to select: name, homeworld, species, films. And so we have Luke Skywalker from Tatooine, a human that appeared in 5 films. And they include at the end of episode 3, Luke appears as a baby. Am I spoiling too much here? I don't think so. So this is, so he appears in 5 of these films, okay? C-3PO, appears in 6 films, etc., etc. This is what we have. Whereas R2-D2 appears in all 7. So this is what we have here, okay? We select the columns here, okay? Now, throughout dplyr, what you're going to be seeing, oh, I forgot, I left this here on Friday, and it's still here, okay. We can use this operator called the pipe. This is basically a way for us to kind of link the results from one previous operation to the next operation, okay? Now, classically, a lot of times, like, maybe when you take stats 20, you're going to be taught this is how you create a table or a data frame, and then you'll save it, and you'll see, you've already learned how to save vectors and stuff, and you save the data frames in the same way. And a lot of times you're going to be told, you take this operation, and then you save it, and then now you take the new data frame, and you do something with it, and then you save that, and you kind of have to create this thing of a series of saves. With the pipe, you can just kind of say, hey, take this result and pipe it or pass it along to this next function. Take that result and pipe it and pass it along to the next function. And you can kind of think of everything as happening in this sequential fashion. So here we can say, take the data frame Star Wars, which is this full thing, 87 rows, 14 columns, and pipe it into the select function, okay? Now, the select function, the very first argument's always the data frame that it works on, but when it receives the pipe, okay, when it's receiving Star Wars through the pipe, it's going to know I'm working with that Star Wars data frame, and therefore, the only arguments we need to provide now are which columns to select. And so this command up here, select from Star Wars, name, homeward, species, film, is exactly the same thing as pipe Star Wars pipe into select name, homeward, species, film. So this gives you the exact same results there, okay? The shortcut to insert the pipe while you are using RStudio is Control or Command Shift M. You don't have to type in % greater than %. I think on DataCamp, you have to type in % greater than % in order to get the pipe, because that, you're working in your browser, and so that keyboard shortcut doesn't exist. But while you're working in RStudio, you can just hit Control or Command Shift M, and this will insert the pipe, okay? All right, so we can do all sorts of stuff as far as select goes. We can say from Star Wars, select, and you can put a minus sign. You can put a minus sign in front of variable names, and it will select everything but those variable names. So we're going to say, I don't want the name, I don't want the eye color, I don't want the birth year, and this is what we've got, okay? So we're going to take a look at that. Here, this command, this head command, says just give me the top part of the resulting data frame. So, in our data set, we have 87 rows. By default, it's going to give you back all 87. It'll generally only print out what it can fit on the screen, but you can just say, you know what, I don't even want all of that. I only want to look at the top 3. And so this is what we have. Yes, question?
One question. What does DBL?
DBL, okay. So we have not gotten into this, but these are different data types. Int is for an integer. DBL is for type double. Double basically means it's a number that can allow decimals, okay? Well, you might call this a floating point number, but basically if it's got decimals and it's a number, we call it a DBL, a double, type double. Yeah, question?
Is the pipe applying to both the select and the
I'm sorry, what's your question again?
Is the pipe applying to
Yeah, so here, so we got Star Wars, we pipe it into select, and the result of this selection, okay, so what is the result? So Star Wars starts off 87 by 14. After this select, we're going to be left with an 87 by 11, and then we pipe that 87 by 11 data frame into head, and the result of the head will just be a 3 by 11. Okay, so each of these operations subsequently kind of modify the data frame, and you're passing the result of it onto the next function. Yeah, question.
Why we don't need to like include Star Wars in the select function?
Because that's how the pipe works. So the pipe says whatever. So this thing, right? So we've done Star Wars. The pipe says take Star Wars, and this will become the first argument of select. Okay. And so the first argument of select is now this 87 by 14, okay? And then it says the result of this thing is an 87 by 11, right? But it doesn't have a name. We're not calling it Star Wars 2 or like a lot of times you would take the thing and you would rename it and you'd say, hey, this is Star Wars data frame 2 or something, right? Star Wars 2. But we didn't name it. We're just saying take that thing, 87 by 11, and type it into head, okay? And head would often also take multiple arguments that say, okay, take this thing and give me only just, you'd give it the data frame name and how many rows from that data frame name you want.
So it's like the pipe provides the first parameter to the head one?
Yes. Okay, question?
Everyone does that function has a parameter. I specify the parameter I'm sending it.
Yes, so your function, yeah, so with the pipe, there's the details of using the pipe is in a package called Mutate. Okay, I don't know if you guys are there's all right, detour here. Okay, the treachery of images. Okay, so this was I don't know if you've seen this image. And it says this is not a pipe, okay? And it's to say because it's a picture, right? It's a painting of a pipe. This thing is not a pipe; it's a painting, and that's the thing. And so this is academic humor for you. All right, we're going to name our pipe function after this artist Magritte, okay? And so this is we've got the pipe here, okay? But anyway, the details of that are in the name of that package, Magritte. And yes, you can specify other arguments. If you've got 10 arguments or something, you can name them. You can say x equals, y equals in this thing and pass them along. It's designed to work very well with this dplyr or this tidyverse thing. But yes, you could use them with other packages as well. Okay. All right. Here is, you can use colon notation, which will just say select from this column through this column, okay? So if I go back to the original data set, we could say the first column is name, and I want to select through iColor. So I could say name colon, the colon will basically say start here and end here, okay? And that works if you want to pick columns that are adjacent to one another. So that's what we've got here. Select from name through iColor, select those adjacent columns, take that result, give me back the first 3 rows using head 3. Okay, there's more special kinds of helper functions as far as selecting, okay? We've got contains, starts with, ends with, matches, everything, num range, one of, okay? And so these are things like select columns that contain a certain character string. So you can say, I want to select all the columns with the word color in them, and you'll get hair color and eye color or something, right? Starts with this letter, ends with this letter, matches some kind of regular expression, which we haven't got into, but that also exists. Everything, select all columns. So here is a few examples. From Star Wars, select the name plus all columns that end with color. We get name, hair color, skin color, eye color. Okay? Here we could say Star Wars, select name matches, and this is a regular expression, and we haven't got into regular expressions, and I don't really intend to get into regular expressions, but this is a regular expression that says ends with the letter S. Now, I could have just done ends with character S, and that would have been equivalent, but with regular expressions, if you were to learn regular expressions, which I cover in 102A, you can do a lot of powerful things with them. Okay, so this will give me the name column, because I specified that one outright, and these are all of the things that end with S: mass, species, films, vehicles, starships. Okay, you can also create a vector with the names of the columns you want. So here's a vector that says name, mass, height, okay? And we're going to say select all of these variables. Select all of the names that appear here, and we're going to select name, mass, and height. And you can see I did not pipe this into head, and so the result is just going to be all 87 rows. dplyr just prints out the first 10, but says there's 77 more rows, and it tells you, the result is 87 by 3. All right, let me give you your second view quiz answer. Second view quiz answer is E. E as in elephant. E as in elephant is your second view quiz answer for today. Okay. Yeah, question?
So when you create a Dutch vector or these type of commands, you have to put the quotation marks and then put like the select.
You don't. Oh, yes. Yeah, okay, sorry. For this part, yes. If you're going to create this vector with the names, you got to put quotes around them. Whereas when you just use the standard select thing, you don't actually need to put quotes around them. Okay. Okay. Filter says which rows do I want to select? Okay. Which rows do I want to actually filter down to? I shouldn't use the word select. So select is for columns, filter is for rows. All right. So we could say the full data set, 87 rows, 14 columns. Filter it just to the row where the column name is exactly equal to R2-D2, okay? And that will give us the information about the character R2-D2. Okay? You can apply multiple kind of conditions. All right, so here, the condition I said, the species is inside this vector, okay? The vector containing the characters human or droid. So this will give me back all human or droid characters, all right? That's what this %in% is, okay? So it says, give me back a species that's in either human or droid, and their height has to be less than 175. Okay, yeah, question?
It's likely.
Okay, go for it.
Is this one a SQL at all? It's not readable.
It reads very much like SQL, but it's not, okay? But yes, if you're familiar with SQL and how to go about selecting records from a SQL database, you'll feel comfortable with this because a lot of things are similar. It's different, right? The notation for SQL, you have a select, but you use like where in SQL and things like that and stuff like that. So there's a lot of similarities, but it is distinct from it. Okay, so we have this. Yes, another question.
Why did you have to define what species was?
What I didn't. I mean, this is just an example of data that I wanted. I didn't have to, right? This is just like somebody asks the question, hey, can I get humans and droids from the data set? Yes. Okay. Now, we're just kind of playing around with this. We don't have real questions to answer just yet, right? But somebody says, hey, you know what? I want all of the Wookiees or something, right? Named Wookiees. Probably just Chewbacca. I don't know. Is there another Wookiee that's named in the movies? I'm not sure. But whatever, right? You know, I want all of the, what is Yoda's species? I have no idea. But now we have 2 in those characters, right? So, Grogu and, okay, so anyway, you can specify whatever you want, right? We could have just as easily said, you know, I want all characters with eye color is blue or red. I want blue and red eyes only, or something, right? Because apparently R2-D2's eye is considered to be red according to this data set, because I guess he's got that little light. I don't know. All right, you can have ors. Okay, so you can also say I want people who either have no hair color equal to none. Now notice the equals is a double equals. Okay, this is how we specify a test for equality. Okay, so we're going to say I want people either with hair color none and or eye color black. Okay, and so we get Darth Vader, who has no hair. Okay, we have Greedo, who has black hair. We have all of these droids with no hair. Okay, and then we have Nienund, I don't know who this is, of the Celestan species from Celeste. This person has both no hair and black eyes, and is this the guy that plays a little trumpet thing? I don't know. I don't know who this character is, okay? But anyway, this is what we have. Now notice again, we do the filter. This reduces it to 38 rows, and from there we pass that on to select and say I only want these 5 columns, and so the result is going to be a 38 by 5 data frame or tibble. Okay, is this all right? The usage of kind of these operators together. Okay, I gotta work quickly here. I only got 10 minutes left. So a range is used to kind of sort, right? So you could say I want to arrange these by birth year, okay? And you can say I want them in descending order. And then if there's a tie, break the tie based on mass. Now mass does not have descending placed around it, so it's going to go in ascending order, okay? So it takes the oldest character, Yoda, and then Jabba, and then Chewbacca, and okay, and now we have a tie between Palpatine and Cliegg Lars. Okay, 82, 80. Oh, I guess we got an NA here. Let's see. Okay, Ki Adi Mundi and Qui-Gon Jinn have the same age, but then we break their tie and we sort them based on mass. Okay, ascending order. Sort rows using a range. Yeah, question. Oh, I couldn't hear you at all. I'm sorry.
If you want to sort by ascending, you just grab it.
Yeah. The default is ascending order. The smallest ones go top, larger ones later. But if you want that reversed, you use the descending option.
Can you please go back to the
Yeah.
So the only one the first here to be descending orders, call it mass result. Mass also in descending order.
Yeah. Then if you want mass also descending order, then you just put the operator, the option DESC around mass.
The default is ascending order for mass.
Yeah. The default for anything is ascending order.
Right.
And if you want it backwards for that particular variable, you put descending around it, DESC around it. Okay? And you could have like 5 of these things if you think there's going to be a lot of ties and stuff. Okay? Okay. You can also say, I just want rows 5 through 10. Okay? So rows 5 through 10, this is just from the original data set, which may or may not have had like, I don't know if you look at the original data set, they were just in some arbitrary order. And so here we're just saying I want rows 5 through 10, et cetera, et cetera. Okay, that's slice. Slice sample is a way to just kind of randomly select rows. You could say, I just want to select 5 rows kind of arbitrarily or randomly from the data set, and we have this, okay? Now, the reason why you might want to use slice sample rather than just slice or head is because perhaps your original data set is in some order, right? It has maybe all of the humans at top, the droids next, and then the alien other species later. And if you only look at head, you're only going to be looking at the human characters or something. Now, perhaps you've done some kind of operation that successfully works for humans, but for whatever reason didn't work for the droids, okay? Now, if you just do head every single time, you're only going to see the human results, and you might be tricked into thinking it working fine for everybody, but perhaps it's not. So slice sample will kind of just select rows across the thing, and you can kind of look at your results and say, okay, working good for the humans, working good for the droids, working good for the other species, we're good here, okay? But again, maybe you can also catch when something's going wrong, right? So here we've got, I don't know who these other what these species are, but this is what we have, okay? You got slice min and slice max, and this is kind of like a combination of using arrange with head. So arrange would sort them, and head would pick the top whatever, right? So you could think, arrange them from least to greatest, and then select the top 3. That would be the same thing as doing slice min 3. You're just taking the ones with the 3 lowest for this particular variable. So this is going to be, give me the, I'm sorry, this, slice max here says give me the, arrange them in descending order and give me the ones with the 3 largest masses, okay? So we've got Jabba, and then I don't know who these other characters are. IG-88 is, I think, the bounty hunter, so. Okay, mutate. Mutate allows us to create new variables, okay? It allows us to do some kind of operation to create new variables. So here, height is currently measured in centimeters, but let's say you are American and want things in inches, okay? And so you say, okay, Luke is 172 centimeters. I don't know what that means, okay? So you take the height. The conversion factor is to get the number of inches, you take the number of centimeters, divide by 2.54, and that will create the thing. Now, you have to give it the new name for your new variable, right? So here I'm going to do height underscore in for a height in inches, okay? So this will be my new variable name. Now, the default behavior of mutate is to take the new column that you've created and put it all the way at the end, okay? So now I said, give me a new variable called height in inches. I want the top row, head 1. So the result is going to give me 1 row, 15 columns, because now the columns that didn't fit are vehicles, starships, and height in inches, okay? Height in inches. But I'm like, oh, I actually wanted to see this, okay? And it doesn't fit in on my paper here. So I can go, now I can take that and say select, create height in inches, take that result, which has 15 columns, and now give me the name, the height, and the height in inches, okay? And so we can see Luke Skywalker, 172 centimeters, 67.7 inches. So Luke Skywalker is around 5 foot 7.7, 5 foot 8 in here, okay? And head 1 being, this is just the top row here, okay? Okay. Now, when you create a new variable using mutate, the result has to be the same length. That new column has to have the same length, the same number of entries as there are rows in the table. So I've got 87 rows in the original table. Whatever new variable I make also needs to have 87 entries. It needs to have 1 entry for every single person. So if I just used the variable or the function mean, take the height and give me the mean, that will not work. Because the mean takes, if you have 87 numbers and say give me the mean, it only gives you back 1 number, right? So any kind of these summary functions, like give me the median, give me the standard deviation, the variance, all of these things take a bunch of numbers and summarize it down to one number. So that's not going to work. But you can use something called the cumulative mean, and this will work, okay? The way the cumulative mean works is it says, okay, your first number is 77, so what is the running mean so far? The running mean so far is 77. The next number is 75. What is the running mean of 77 and 75? That running mean is 76. Okay, what's the next number? 32. Okay, the running mean of these three numbers, 77, 75, and 32, is 61.3. We've got a question.
What's the point using cumulative mean on
Yeah. There's no point, right? So this would be a bad use of cumulative mean, or cumulative mean could be useful for something like you've got like this random sequence and you want to see kind of the mean even out over a period of time or something, or you could take a look at I don't know, like income numbers. This is not a very good use of this function for this data set. I can't think of anything meaningful coming out of this column. So that's a valid concern. This is mostly an example of just some kind of function where the result will give you the same number of results same number of values as the column that you put in, okay? So these are examples of functions that you can use with Mutate, okay? So you have what's known as the element-wise min and max, p-min, p-max. You have the cumulative mean and max. You have the cumulative sum, the cumulative product. You have a between, which will give you a true false. Is the number between this and this? You have the, cumulative sum and cumulative mean. You also have lead and lag, and you have the n-tile, which will bin the vector into n buckets. And so I think this will be our last slide that I have time to show you, where I've just done a whole bunch of these examples all on one table. Now I'm going through this fairly quickly in class, but this hopefully will serve as a good reference point for you to kind of look back and say, hey, what is this thing? And again, I see an example of that. Before I go into each of these columns, let me give you your last view quiz answer for the day. Today's last view quiz answer is the letter B. B as in bear. B as in bear, okay? And again, you know what? So on Wednesday, I will work through the group by and summarize, and then we'll do some, a live example in class that you can follow along with if you have your laptops. But here, let me just talk briefly about some of these examples here, okay? So we have the cumulative min mass, okay? And this will just give you the smallest value it's seen so far, okay? So as far as the mass goes, the first value is 77. The next value it sees is 75. Okay, it says, oh, okay, that's the smallest. The next value is 32. And it says, thus far, the smallest value I've seen is 32, and there just remains 32 for the rest of the data set. We don't see anything smaller than that. The ratio here is just mass divided by the mean of the mass. So we can kind of ask, what is the average weight? Okay, what is the average mass? All right, and then take that number and divide by the average mass. Now, anytime you calculate the mean, if you have a missing value, it's going to say, I don't know what the true average is, right? You got three numbers. What one of them's missing? What's the average of the three numbers? Well, if one of them's missing, you don't know what the average is. So you just have to say, well, if you got three numbers and one's missing, just take the average of the remaining two. That's what we're using here with this option. na.rm says just ignore any missing values. All right, so give me the mean of the masses that I do know, and then we'll just get a ratio there, okay? P-min, mass and birth year. Again, this is a completely meaningless statistic. Which one's bigger, your mass, or which one's smaller, your mass or the year you were born in, okay? But here it just says, product-wise, which one's smaller? 77 versus 19? 19 is smaller. Which one's smaller? 32 or 33? 32 is smaller. Which one's smaller? 136, 41.9. 41.9. Now this might make more sense if we're talking about, like, if you've measured different parts of a machine. You could say which one of these four elements, maybe you say, you've got the front left thing and the front right thing and the rear left thing and the rear right thing. You can say which of these four things is the heaviest. You can do the P max. Which one of those four is the minute? Now in this example, I don't know why you'd ever want to say, oh, my mass is bigger than my birth year. It's kind of a silly thing, right? Lag just takes the column and it delays it by 2, or lead would do the opposite. So here it just takes this column 19, 1, 12, 33, and it delays it. I'm sorry. It takes this column, the mass year P min, 1975-32, and it delays it by 2, 1975-32. Now, it doesn't make sense, again, in this context, it's completely meaningless, but if you had like a time series thing, where it's like, this was January, this was February, this was March, and you want to do a comparison between this month and 2 months ago, something like the lead or the lag would make sense. Okay? Again, these are examples that are silly. All right, sorry for going over, but that's it for today. Have a good day, and we'll see you guys on Wednesday. If you have a laptop that you can bring it to class. If not, no worries. You can still follow along.
Professor?